Hey guys, Mrs. Dan's here. So today we're on lesson 2. If you can copy down the objective and start doing your do now if you're waiting for others to finish copying. You should also write down what your homework is. Your homework will be to do lesson 2 problem set, which is on pages 8 through 10. So again, just make sure you have the objective down, and the first part of your do now, I have the definition written for you. If you need to have someone pause the video, please raise your hand and they'll do so. So for part B of our do now, this is way back to like October when we learned how to write the equation of a line. Remember that the equation of a line can be written in the form of y equals mx plus b. So by looking at this, if I assume these tick marks are going by 1, which I have to assume that since they didn't tell me anything else, it looks like the y-intercept, which is your b, is at 4. The slope, which we use the letter m for, looks like it goes down 2 over 1, down 2 over 1, down 2 over 1. Negative 2 over 1 is the same thing as a negative 2. So the equation can be written as y equals negative 2x plus 4. If you can do that, today's lesson is going to be easy. Today it's about writing the equation of the line that best fits a scatter plot. We talked about yesterday how we don't connect the points in a scatter plot. We like to see if there's a certain path that the points follow. So this is asking us to sketch the line or the curve that best fits the data. So I think this is an upward path. So I feel like I could draw a line like that. The next one is like a downward sloping path. So I feel like I could draw a line like that. So there's a rule that we follow actually when we're drawing this line that represents the path of the points. And the rule is that the best line, write this down with me, or curve, because sometimes it's a curve, is the one that follows the path and, so this is very important, this and it has about the same number of points on each side. So we're going to go back and look at the lines I just drew. This line is following the path, and I do have some points above the line and some points below the line. Some people, sometimes after they draw it, they erase and try again, like maybe it should go a little there. Now maybe it's a little bit better. This one maybe a tiny bit down. Right about there. Okay, so really you're drawing a line that follows the path and is about the same number of points above the line as below the line. This, to follow the path, I have to curve it. And I have about the same number of points on one side of the curve as on the other side. This I can't draw anything. I don't know which way it's going. This has no correlation, or in this case it says no association. If we take a look at the top of the next page, I'm going to draw some lines on here. Notice all these points are the same. I'm going to draw a different line on each one, and you're going to tell me which one you think is the best trend line. So if I draw something like this, or if I draw something like this, or if I draw something like this. So would it be choice 1, choice 2, or choice 3? I'm hoping you all think choice 3. So in choice 1, my line followed the path of the points, but I didn't have the same number of points on each side of the line. There's no points on this side, so this line is not in a correct spot. This one, it seems like I have about the same number of points on each side of the line, but this isn't following the path as best as it could. This one is following the path and is about the same number of points on each side. So that's what we look for. So we have to draw a trend line, which is also called a line of best fit. I think something like that looks good. And on this one, something like, I think something like that. I like step back and I look. You know, some lines are easier to draw than others. This one, the points were so close to the line that it was easier. This one, you know, this one's kind of far, but I have some that are far over here. Should I shift my line a little bit is what I'm wondering. That just looks too high though. I think I like it right there. So I really do, when I'm doing it by hand, I use a pencil and I do erase sometimes. In exercise 3, they have the line for us, but they're asking us to write the equation. So here's what we do. We have to extend this line so that we could see where it hits the y-axis. Because to write an equation of a line, it's in the form of y equals mx plus b. I want you to first find b. I like finding b first. And this one looks like it's at 0. Looks like it's at the origin. Then I want you to find m. M is the thing that's a little trickier to find because you can't always count rise over run. So what you do is you pick 2 points. I'm going to pick this point because it's nicely on the line. That looks like it's at 3.5, comma 3. I like to pick points that are on the line but not too close to each other. I wish there was a nicer point down here. I'm just going to pick this one. That looks like it's at about 2.2. And 2. So remember what we learned about slope is that we could do y2 minus y1 over x2 minus x1. We did this earlier in the year. I could go like label these x1 and y1 and x2 and y2 and plug them into the formula. So I would do 3 minus 2 over 3.5 minus 2.2. And I would allow a calculator on this stuff because sometimes maybe it's a little tricky for you guys to figure out. I know that 3 minus 2 is 1. And I can do 3.5 minus 2.2. I get 1.3. But now what is that equal to? So I'm going to do in my calculator 1 divided by 1.3. And I'm going to round my answer. So I'm going to put a squiggly equals. It's approximately 0.77. So now I can write y equals 0.77x plus 0. I actually don't need the plus 0. I could write it as y equals 0.77x, which means it's like rising a little less than 1 and then over 1. So if I go up a little less than 1 and over 1, yeah, it seems like I'm on the line. Do you see that? Up a little less than 1 over 1, I'm on the line. So You do want to calculate your slope. Your y-intercept is something we just eyeball. We look at it to see. So it's asking us to go back up to the two questions and write the equations. I'm going to look up here. It looks like my y-intercept is about 0.5. And my slope, what's that look like? Looks like my slope is up 1 over 1. This one I feel like I can count 1 over 1. So I'm going to write that y equals 1x plus 0.5. This one, I don't think I'm going to count my slope though. I'm going to say that the y-intercept is at about 4.5. My slope, I'm going to calculate. I'm going to pick a point. I like right there. Even though it's not a plotted point, I could put a point there myself, and that's at 3, 2. So sometimes I pick my own points. How about this one here? Doesn't that look like it would be at 6, 0? So if I do y2 minus y1, I'm going to do 0 minus 2. So this is my y2 and this is my y1 over 6 minus 3. I get negative 2 over 3. That makes sense. That's negative. It's going downward. And my equation then would be y equals negative 2/3 x plus 4.5. When we write these equations, especially when it's time for a test, I have to accept a few different answers. Depends on what you think the y-intercept looks like. Like someone might have said 4.4. I have to accept. And some people would have maybe picked different points for their slope and got a slightly different answer. So I would have to accept. But you have to show your work so that I could follow and see what you're doing. All of these, you have to state whether it's positive or negative and write the equation. So why don't you give a few of them a try. Maybe the video can be paused for a second, and then you can check your stuff with mine. So I'm going to do these, and if you already started doing them, remember some of our answers may be slightly different, and that is acceptable. To me, it looks like the y-intercept is at 140, and I'm going to choose that point because I can clearly see it. It's at 20, 130, and I guess I'll choose this point, which is at 30, 125. So if I find my slope, I could do 125 minus 130 over 30 minus 20. So I get negative 5 over 10, which is negative 1/2. So my equation is y equals negative 1/2 x plus 140. Makes sense it's negative because it's going downward. This one I'm going to say my y-intercept is at 1,000. And I'm actually going to pick this point right here. 0, 1,000. And how about this point right there? 5, 2,000. So I'll do 2,000 minus 1,000 over 5 minus 0. I get 1,000 over 5, which turns out to be 200. So y equals 200x plus 1,000. It's going downward, so I'd expect it to be a negative slope. The y-intercept to me looks like 35. What points am I going to pick? I don't know, I can kind of guess what this point is. It's 48, 14. Because because it's almost at 15. And what if I use this point again? Like I did on the other problem. This is 0, 35. So I'll do 14 for my slope. I'll do 14 minus 35 over 48 minus 0. This is going to be negative, what is it? 14 minus 35 is negative 21 over 48. I'm going to divide those. I'm assuming I'm going to have to round. So 21 divided by 48 on my calculator gives me 0.4375. So I am going to round. It's negative 0.44 about. Keep on rounding to the hundredths place. On your test, it will clearly tell you where to round. The equation will be y equals negative 0.44x plus 35. This has a positive slope. I'm going to say that the y-intercept looks like it's at about, what do you think, 51? And points. I don't know, this looks like I can make it a point. That would be 2, 60. And then one over here, how about that one, which is 6, 80. So when I do my slope, I'll do 80 minus 60 over 6 minus 2. That's 20 over 4, which is 5. So y equals 5x plus 51. So if you notice, I keep on just looking to see approximately what I think my y-intercept is. But for my slope, I keep on picking 2 points, and I do the y2 minus y1 over x2 minus x1. So your homework is on the next 3 pages, 8, 9, and 10. I hope this was helpful, and hope you enjoy the rest of your day. See ya. Bye.